Hi intermediate kiddos. I am going to have you listen to another video, kind of do a flipped classroom model so that kids can finish their test today and then we can all be on track on Monday. So we are going to learn about linear versus nonlinear today. So please fill out your essential question. How can you tell if a function is linear? And then we are going to go through what linear and nonlinear mean. And continue from there. So as you can see, linear functions are ones that their graphs are non-vertical lines. They are a straight line. So if you see a line that increases, decreases, or is a straight side-to-side line, those are all examples of linear lines. Non-linear lines are ones that maybe curve. This is called a parabola. Or maybe go like that, or be like this, or like this is the absolute value line. Any of those are examples of nonlinear because they are not a straight line. So go ahead and write that down. Again, I'm going to keep working through and you pause when you need to. So our first problem, our first part, determine whether a graph is linear or not. So remember, linear functions are ones that incorporate a straight line, ones that do not curve. Well, there's only one of these that is actually linear. So this one does not create a straight line, so it is nonlinear. I'm going to put NL. This second one, straight line, going at a constant rate, linear. This third one is called a parabola. It's not a straight line. It actually has it where it's nonlinear because this exponent is greater than 1, and we'll talk more about that in a minute. And then this is not a straight line. Parts of them are, but the whole thing is not. It has to be consistently straight, so nonlinear. So only one of these is actually a linear line. So now when looking at an equation, to figure out if a function is linear, it needs to be, or it should be written in the form y equals mx plus b, or something similar to that, where your x and y values are an exponent of 1. So as you can see, this is just y, no other exponents. Just x, no other exponents. So if you see anything additional to where it has to the second power, to the third power, to the fourth power, etc., or to the x power even, those are all considered nonlinear functions. So knowing that piece of it, looking at part B, determine if it is a linear or nonlinear equation. Well, letter A has that exponent of 2, so it is nonlinear. Letter D has the exponent of x itself, not linear. B and C, look how there is no exponents here. They are exponents of 1, linear. And B, same thing, also linear. Actually, B is not, but we're not going to get into that. So technically, it is not linear. What you need. What's that for? Oh, yeah. There you go. You're welcome. All right, so linear functions increase or decrease at a constant rate, meaning when you have that y equals mx plus b, or just y equals mx, this value of m, your number in front of the x, is the rate that it goes up by. So what that also means is your change in y over your change in x should be the same each time. So if I take each of these, they should divide to be the same. Nope, that's not what I meant. Sorry, brain fart. If I take the change, so increasing by 1, increasing by 1, increasing, by 1. So my x's are all going up by 1. This, decreasing 1, increasing 1, increasing 3. Well, is negative 1 divided by 1 the same as 1 divided by 1 the same as 3 divided by 1? Nope. So this is actually a nonlinear function. So what you're doing is you're taking the difference of two x values the difference of two y values, and you are dividing your y by your x in order to see what the constant rate ratio is. So let's try it for this next one. -5 to -4 is increasing by 1. Again, increasing by 1. Again, increasing by 1. So if I look here, 2, oh, my bad, 3, 4. So if I take y divided by x, 2 over 1, does that equal 3 over 1? Does that equal 4 over 1? Nope. So again, this is nonlinear. So here's an example of a linear one. So actually I want to give you an example. X, y. All right, so if I have -2, -1, 0, and then I'm going to actually go up to 2. And then 4, 6, 8, 12. So now watch what I do here. Go with this blue. So each of these, let's see, we got increase 1, increase 1, oops. So increase, increase, increase 2. Now on this one, increase 2, increase 2, increase 4. Now you may be thinking, well, 1, 1, 2, 2, 2, 4, they're different. But watch what happens. 2 over 1, because again, y divided by x. Does that equal 2 over 1? Yep. Does that equal 4 over 2? Well, 2 over 1 is 2. Oops. 2. 2 over 1 is 2. 4 over 2 is 2. So this is actually a linear function. So when your y values increase by the same amount, or the ratio of y over x results in the same number, it is a linear function. All right, our last piece is to graph and then to determine if it's linear or nonlinear. So I'm going to make a table. I'm going to go our usual suspects of, and also when you graph, these are your usual suspects. -2, -1, 0, 1, 2. So if I were to plug this in, -2 times 2, because I just substituted in. -2 times 2 is -4, plus 0 is -4. So if I were to solve, I would get 0. So my point is -2, 0, -2, 0. Now also I can look at this graph and I can say, well, I'm going to guess that it is linear because x and y don't have exponents, but we're still going to check. So -1. So actually I'm going to solve for y because this is going to make it easier. So y equals -4 minus 2x. So -1. So -1 times -2 is 2. So -4 plus 2 is -2. So at -1, oh, I did that wrong. Oops, I graphed my first one wrong. Good thing I got that. -2, 0 is here. -1, -2. So then 0 would be -4. I don't have to really plug that in. This turns into 0. So 0, -4. So then 1 would be -4 minus 2 is -6. Do you see a pattern of a graph right now? So then this would be -8. Does this, if I actually graphed it right, make a straight line? It does. And the constant rate, if you actually look, is right here, is -2. So it is a linear graph. All right, and this last one, I have my table. I just have to graph it now. So 0, 0, 2, 1, no, graphing wrong. 2, 1, 1, 2, 3, 4, 1, 2, 3, and 5, 6, 4, 5, 6. Well, oh my god, if I could graph this right. Boop, boop, boop. That straight line? Nope. Even though I didn't graph it right anyways. But this would be a nonlinear equation. All right, guys. So we have gone through how to look at a graph, how to look at points, and how to look at graph equation in order to see if it is linear or nonlinear. So go ahead into Math Excel now, and you can work on your homework.